In this video, we are continuing with the identities. We'll solve few more identities. We have cot A minus 1 upon 2 minus sec square A equal to cot A upon 1 plus tan A. Now here, this seems little difficult. So we will take the right hand side part here. Right? So right hand side mein we have cot A upon 1 plus tan A, right? So we will rationalize this. How do we rationalize? 1 minus tan A upon 1 minus tan A. So what will I get? I will get cot A into 1 minus tan A, and in the denominator I am getting 1 minus tan square A, right? Because it is A plus B into A minus B. Now, if we multiply the contents here, I'll get cot A minus cot A into tan A. See, that's why we chose this right hand side, because minus 1, immediately you should get this idea. If I rationalize, I'll get tan A and cot A cancelled, right? So I'll get 1 here divided by, now in the denominator I don't want tan, I want sec square A. So what do? I will convert this into sec square A minus 1, right? So I will have cot A minus, this will get cancelled and we will have 1 because they are reciprocals of each other, upon 1 minus sec square A plus 1, minus becomes plus. Now this becomes cot A minus 1 upon 2 minus sec square A, because 1 plus 1 is 2. Is that your left hand side? Yes. So you have proved your left hand side equal to right hand side. Whenever you see a sum, any identity in the square root, so the first thing that should come to your mind is that I have to rationalize this. So let me take the left hand side, and now I am clear what is the left hand side. It is 1 plus cos A upon 1 minus cos A, right? So I'll rationalize it as 1 plus cos A upon 1 plus cos A. So what will I get? I will get 1 plus cos A into 1 plus cos A is 1 plus cos A whole square. And in the denominator, I will get 1 minus cos A into 1 plus cos A is 1 minus cos square A. A minus B into A plus B is A square minus B square. So further, this is 1 plus cos A whole square upon sin square A. Now, this will come out of the square root, right? I will get 1 plus cos A upon sin A. So if I split this and write this as 1 upon sin A plus cos A upon sin A, this becomes sec A, cosec A, and this becomes cot A. That was my right hand side. So I have proved my left hand side is equal to right hand side. Clear? Whenever you see any identity in the square root, what you have to do is just rationalize. Here, one more. So I will take the left hand side. What is that? Under root of 1 minus sin A upon 1 plus sin A. Now I know I have to rationalize this. So 1 minus sin A upon 1 minus sin A. So this makes it under root of 1 minus sin A whole square, and in the denominator you get 1 minus sine square A. So which is further equal to 1 minus sine A whole square upon cos square A, because 1 minus sine square A is cos square A. So it will come out of the square root as 1 minus sine A upon cos A. Now let's split this. What will we get? 1 upon cos A minus sine A upon cos A. How much is that? 1 upon cos A is sec A and this is tan A. Is this my right hand side? Yes. So I have proved my left hand side equal to right hand side. Now one more type here. I have cos A, this is my left hand side, upon 1 plus sine A plus tan A. Right? I have to prove that this is equal to sec A. So whenever you see something like this, as you saw here also, so rationalization is something that should come to your mind. So let's rationalize this. This is cos A into 1 minus sine A upon 1 plus sine A into 1 minus sine A, plus this tan A can be converted into sine A by cos A. So we have cos A into 1 minus sine A upon 1 plus sine A into 1 minus sine A is 1 minus sine square A plus sine A upon cos A. Now this becomes cos A into 1 minus sine A upon cos square A plus sine A upon cos A. So what will you do with this? You multiply this, you will get cos A. Oh, you can take cos square A as LCM. So you will get cos A minus cos A sine A plus cos square A, so cos A sine A. This term and this term will go. You will be left with cos A upon cos square A. So 1 cos A and cos A will go. You are left with 1 by cos A, which is equal to your sec A, which is equal to your right hand side. Right? Okay, one more type here. Let's write the left hand side. What is my left hand side? My left hand side is cos A upon 1 minus tan A plus sine square A upon sine A minus cos A. Right? So let's convert this tan A. What will we get? We will get cos A upon 1 minus sine A by cos A plus sine square A upon sine A minus cos A. Now cos A upon, I can take cos A as LCM here. So here I will get cos A minus sine A plus sine square A upon sine A minus cos A. Now this cos A will come up and it will become cos square A, and in the denominator I have this cos A minus sine A, then plus sine square A upon sine A minus cos A. Now what should I do further? Here I have cos A minus sine A, here I have sine A minus cos A. So I can make this as cos A minus sine A. How? By taking minus common here, so that I can take cos A minus sine A as LCM. So let me write that. I will have cos square A upon cos A minus sine A minus sine square A upon cos A minus sine A. Now it is easy for me to take the LCM. Now I'll take the LCM as cos A minus sine A. So what is left here? Cos square A minus sine square A. Now this is A square minus B square. This I will further split as cos A plus sine A and cos A minus sine A plus B into A minus B, divided by cos A minus sine A. Now this and this will go. I am left with cos A plus sine A. Is that my right hand side? Yes. So I have proved my left hand side equal to right hand side. Just a reminder, never ever shift the terms when you are proving the identities. The left hand side term should be on the left hand side and right hand side term should be on the right hand side. You are not allowed to make any shifting. Now, one more. Here you have cot A minus tan A equal to this. Now, when you will, by now you should be able to think that how to solve this. Simply you have to convert because there is no square here. So we will write the left hand side part. What is that? Cot A minus tan A. I know that I have to convert everything into sine and cos. So let me write this as cos A by sine A and this as sine A by cos A. So what will be my LCM? My LCM will be sine A cos A and here it will be cos square A minus sine square A. Now, when I take a look at my right hand side, I don't have sine square anywhere. I have cos square. So here I have cos square and sine square also. So what I will do is I will convert this sine square. That's how you have to think. You have to link. So cos square A I will keep as it is and sine square A I will write in terms of cos square. So sine square A I can write as 1 minus cos square A, right? So I will have sine A into cos A in the denominator. So that makes it cos square A minus 1 plus cos square A. And in the denominator, I have sine A into cos A. Now cos square A plus cos square A is how much? 2 cos square A. And then this minus 1 divided by sine A cos A. Now, is it equal to your right hand side? Yes. So, you have proved that left hand side is equal to right hand side.